Hello dear students. In this video we are going to discuss about forces between multiple charges. So what are multiple charges? When we have a system which consists of more than two charges, we call the system as multiple charges. In this discussion we are going to consider three charges, Q1, then Q2 and Q3. These are the three charges in our system, and we are going to calculate what is the total force acting on the charge Q1 due to the presence of the charges Q2 and Q3. Dear students, we are already familiar with Coulomb's law, right? We know that what is Coulomb's law. That Coulomb's law is very familiar law, is for calculating the electrostatic force between the two charges in a system. When we have two charges, the electrostatic force can be written as 1 upon 4 pi epsilon naught Q1 Q2 upon R square into R cap. This R cap will represent the direction along which the force is acting on it between the two charges. Now the problem is, in this system we have the three charges, then how to calculate the total charge on this Q1 charge? So that is our discussion here. So what are the possible forces on this charge? Let me check this one. This Q1 is located at a R1 distance from the reference point or origin O, and Q2 is at a location R2 distance, and Q3 at a location R3. Fine. And there are two forces actually will act on the charge Q1. One is due to Q2 and another one is due to Q3. So let us first find out what is the force on the charge 1 by the charge 2, which will be represented as F12 vector. So we can write this as 1 upon 4 pi epsilon naught, then Q1 Q2 upon R. This R is the distance between the two charges Q1 and Q2, and this force is actually directed from Q2 to Q1. So this can be written as R21 square, and the direction is R21 cap. But in fact in your textbook they will be writing as R12. But in my context it is the most convenient to write down this unit vector R21, because the force is originated from Q2 charge towards Q1, and that is represented as F12 vector. So this will be most convenient format for writing the force. Similarly, and this force is acting along this direction which is shown here by the dotted lines. Then the force acting on the charge Q1 by the charge Q3 will be represented as F13 vector, and that is equal to 1 upon 4 pi epsilon naught. Epsilon naught, we have already discussed this, is permittivity in free space. Then here Q1 Q3 the divided by R, then 3 1 square R3 1 cap, and this force is actually this one. This is F13 vector and this is F12 vector. Both are in different directions. So the resultant of these two forces will be this one, that is F1. So we are going to write down the resultant force, that is F1 vector, which is equal to, what is that? F12 vector plus F13 vector. When we have more number of charges in our system, we can extend this even up to n number of charges, 1n vector. So that is the procedure here. So how will you calculate this force? That is F vector is equal to 1 upon 4 pi epsilon naught is a constant, so you can take it away. So you will get Q1 Q2 divided by R 2 1 square R 2 1 cap plus Q1 Q3 divided by R3 1 square R31 cap plus and so on for n number of charges. If you limit with 3 charges, then the system will have the total charge on the will have the total force acting on the charge q1 by the presence of other two charges will be represented as this is in fact we call it a superposition principle, we will discuss later. Now I will extend this calculation for uh, many charges, and now the system is having 1 2 3 3 4 5. Okay, so q1 is here, q2, then q3, q4, q5. We have 5 charges in a system. So now we will extend the discussion for 5 charges in a system, and we are going to calculate what is the total force acting on the charge q1. So this I will go with this f1 vector is equal to f12 vector, which is a convenient form, f12 vector and f13 vector plus even up to you can go for n number of charges f1n vector. So what will be the total force on this charge q1, that is f1 vector, is 1 upon 4 pi epsilon naught. Then you can extend this discussion. It is q1 q2 divided by r. The force will act from 2 to 1, so it is r21 square, then r21 cap. So plus q1 q3 divided by r31 square r31 cap, and so on. You can extend this concept up to n number of charges, and finally q1 qn divided by rn1 square rn1 cap. So in this way you can represent, and which is called as a superposition principle. Instead of writing in this way, you can find out the total force by this way. F1 vector is equal to 1 upon 4 pi epsilon naught is a constant. Then we can write this as sum over I is equal to, okay, I is equal to 2 to n. I is equal to 2 to n. In all the terms we have q1. So we can write as this q1, we can take it away. So q1 into qi. If you put I is equal to, you will get q1 q2. So divided by r I, this integral number I will represent 2 ri1 square then ri1 cap, right? So this is the general way, or by superposition principle, to calculate the resultant force acting on the charge q1 by the presence of other charges in our system. And the picture represent how to calculate the total force, that is f1 vector. See, there are 5 forces acting on the charge q1. Due to q2, the force is f21, that is represented here. Okay, this one. And then due to the third charge q3, the force is f31. So we have 2 charges now. One is this one, f21, and another one is f31. The resultant of these two is calculated as this way. So this is the resultant of these 2 forces. Okay, this one, and this one. And now we have remaining 2 charges. Fine. That is 4 and 5. So q4 will exert force along this way. Okay, this is one. And q5 will exert along this. That is this one. And what about this? This is q4. So q4 will exert force along this way. Already we have a resultant force due to the second charge and third charge. Therefore, the resultant of these two will be this one. That is another calculation, another resultant. Okay, this one. Is it clear? Yes. And now we have f51. So you take this one and take the resultant by the parallelogram law, or you can calculate the law of triangle. and actually this one is a parallelogram law to find out the uh, resultant force, and this diagonal will give you the resultant force due to the fifth charge and the resultant of other two charges, and that will be represented by this black line. So this is the way of calculating the total force acting on the charge q1 by superposition principle. So this is very important concept you must know, because when a system of charges is given, you should be able to find out how to calculate the resultant force on a particular charge due to other charges. The same idea will be very helpful to you to calculate the electric field also, that we will discuss in the next video session. Thank you.